Which components minimize ripple in DC power supplies? Imagine trying to keep a steady flow of water in a pipe when the pressure keeps fluctuating. That's what ripple does to a DC power supply. It's the small, unwanted fluctuations in the voltage after rectification. These ripples can cause noise and instability in sensitive electronic circuits. So, how do engineers tame this electrical wave? The secret lies in choosing the right components. The most common tool to smooth out ripple is the filter capacitor. Think of it as a water tank that stores energy and releases it steadily. When placed right after the rectifier, the capacitor charges up during the peaks of the pulsating voltage and discharges during the valleys. Larger capacitors can store more energy, which means they reduce ripple more effectively. For example, a 100 microfarad capacitor will smooth out more ripple than a 10 microfarad one. Using capacitors with low equivalent series resistance, like ceramic or tantalum types, also helps because they lose less energy and filter high-frequency ripple better. Inductors, also called chokes, are another key component. They oppose sudden changes in current. When you add an inductor in series with the load, it acts like a barrier that prevents rapid current fluctuations. Combining an inductor with a capacitor creates an LC filter, which is a very effective way to cut down ripple. This setup is called a pi filter because it looks like the Greek letter pi. The inductor smooths the current, and the capacitor filters out remaining voltage fluctuations, making the output much cleaner. Voltage regulators are like the final gatekeepers. Linear regulators, especially low dropout regulators, actively maintain a constant voltage. They work by adjusting their internal resistance to counteract ripple. This means they can reduce ripple by up to 80 decibels, which is a huge improvement. But they do generate heat because they dissipate power proportional to the voltage difference and current. Proper heat sinking is essential here. Active filtering circuits are more advanced. They use operational amplifiers or specialized chips to sense and cancel ripple dynamically. These are often used in precision power supplies where very low noise is needed. They are more complex and usually found in high-end applications. To handle high-frequency ripple and switching noise, small ceramic capacitors are placed in parallel with bulk capacitors at the output. These tiny capacitors, often in the range of 100 nanofarads to 1 nanofarad, catch the high-frequency noise that larger capacitors might miss. Sometimes, feed-through capacitors are used to further block high-frequency signals and shield sensitive parts from interference. Finally, the design of the transformer and the layout of the circuit board play a role. Using transformers with good core materials and proper winding techniques helps reduce magnetic losses that contribute to ripple. On the circuit board, keeping wiring short, grounding properly, and separating high-frequency and low-frequency parts all help prevent ripple from creeping into the power supply. In summary, reducing ripple in a DC power supply involves a mix of components. Large filter capacitors smooth out the voltage, inductors block rapid current changes, LC filters combine both for better results, and voltage regulators actively stabilize the output. Additional measures like high-frequency capacitors, careful transformer design, and smart circuit layout make the power even cleaner. All these components work together to provide stable, noise-free power for your sensitive electronics.